Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 22, 2025, which was about 4 days ago. The big idea is a memory-driven way to adapt agents continuously without touching the model's weights, and it still hits standout numbers like 87.88%, pass at 3 on GAIA validation, and 79.40% on the test set. The paper is titled Memento, Fine-Tuning LLM Agents Without Fine-Tuning LLMs. And as we'll see later, the implications for agent training efficiency are quite significant. Beyond scores, the method reframes learning as selecting past cases, showing strong out-of-distribution gains, and steady online improvement with minimal compute. Alright, the tweets highlight a memory-driven agent that adapts via online reinforcement learning without changing model weights, citing top 1 GAIA validation with 87.88% pass, at 3 95% simple QA, and notable out-of-distribution gains. Engagement looks solid, with likes in the low hundreds on the leading post. Also, the author shared an official GitHub repo for Memento. You'll find a planner executor agent with memory-based learning, a case bank, and a full MCP tool ecosystem. The repo includes client and server code, interpreters, Seer XNG setup, quick start instructions, environment configs, benchmarks, and examples to run the interactive agent. Alright, the earlier intros set the stakes with headline numbers. Figure 1 summarizes performance and learning behavior. Panel A shows leading accuracy across GAIA levels, which confirms strong top 1 results. Panel B reports ablations across benchmarks, where adding planning and case-based reasoning lifts scores. Panel C presents continual gains over iterations, because memory retrieval and rewriting improve choices. Panel D highlights out-of-distribution boosts, especially on Musique and Bamboogle. Okay, the previous figure covered results, while figure 2 shows the graphical model that drives the agent. The diagram depicts states, actions, and rewards in red for environment dynamics, and memory-driven behavior in blue that retrieves a case, chooses an action, and writes the new experience back. The memory nodes M feed case nodes C, which in turn condition the action that the frozen planner executes. This cycle enables continual adaptation because each step appends a new case and updates retrieval for the next decision. The previous figure outlined the MDP mechanics. Figure 3 shows how the agent runs end-to-end. The left stage presents case-based planning, where the planner reads from a case memory, retrieves K prior state plan reward triplets, and then writes new outcomes back, which refines the queue function online. The middle track maintains subtask memory, so the planner can replan as results arrive. The right stage depicts tool-based execution, where an executor calls search, crawl, video, image, code, math, and doc tools through the MCP protocol. Alright, the previous figure outlined the pipeline, and Table 1 presents the head-to-head results across 7 open domain QA datasets. The table shows that the memory-driven agent reaches 66.6% F1 and 80.4% PM on the weighted average, which clearly exceeds both prompt-based and training-based baselines. The strongest gains appear on Hotpot QA and 2Wiki, where F1 sits in the mid-60s to low 80s, so multi-hop reasoning benefits from case selection. Alright, the earlier table covered open domain QA. Table 2 reports GAIA leaderboard standings by average and difficulty levels. The table shows top 1 validation at 87.88%, with strong level 1 and level 2 numbers, while level 3 remains tougher. The test block lists an 80.40% average leader, and the same approach scores 79.40%, with a notable 71.43% at level 3, which signals solid long horizon competence. These results matter because they compare across agent frameworks under identical scoring. Okay, to wrap, 2 takeaways stand out. First, adaptation moves from model weights into an external memory, so a frozen planner learns through retrieved cases and simple queue learning instead of gradients. Second, this delivers state-of-the-art deep research results with lower cost and steady out-of-distribution gains. Thanks for listening. I am Alex, signing off.